Hello, I'm Steve Larson, engineer with CAT Pumps, and today we're going to talk about pulsation dampening. Where do pulsations come from, and why do we need to dampen them? So what we're going to talk about first is where the pulsations come from, and they come from the nature of a triplex reciprocating pump. I'm going to draw a representation of one revolution of the pump crankshaft. So we go from 0 to 360 degrees. This is 180 in the middle. Draw some every 60 degrees. And so we're going to look at the first plunger. When a plunger starts out on a reciprocating pump, it's at 0 speed. And then during the halfway through its forward stroke, it's at its maximum speed. And at the end of its stroke, it's at 0 speed again. So the curve of the output will look like that. And that's the forward part of the plunger. This is the return where it's bringing fresh water into the chamber. And we're only interested in this scenario with the output of the pump. So one plunger has output like that. Then let's look at the second plunger. Starts at 120 degrees offset and has a similar output like that. Now we'll look at the third plunger, which starts 120 degrees after that and has a similar output. That's what the output of a reciprocating triplex pump looks like. Now, to get a true picture of what's happening, we're going to add what's happening at each moment along here. At this point, only one plunger is going forward, so there's this output. At this point, two plungers are putting out the same amount of output, so we add those. Here, only one is putting out, so it follows this curve from there to there. Again, here it adds. Follows along, adds, and follows along. So the output of the pump actually looks like this. As you can see, that is a pulsation curve, because if we're running at 1,000 psi right through here, that's 1,000 psi, we're seeing peaks up here of possibly 1,200 and valleys down here around 900 psi. So in one revolution of a pump, we have 3 peaks up to 1,200 and some peaks down here at 900 psi. That's very erratic pressure. And it also represents the flow coming out. And so it's very erratic. And what we want is something a lot more smooth than that coming out. So we introduce what we call a pulsation dampener. What a pulsation dampener is, it is basically a device that's spherical in shape, has a nitrogen charging cap, it's open in the bottom, and we put it in line. So this pulsation that's coming from the pump is coming through this piping and hits this dampener. The dampener will have a nitrogen charged bladder in it at about 60% of operating pressure, or in this case 600 psi in here. And when this pressure is in here, it holds the bladder to the bottom at 600 psi. Now we come in here with our 900 to 1200 psi ripple. It energizes here, pushes the bladder up to this position. So now we have 1,000 psi on both sides. And this ripple is coming in and going out, and the bladder reacts to that. When a spike comes up, it goes up a little bit. When a valley comes in, it comes down a little bit. So it compensates this flow and gives you a much more smooth output. Possibly a range from 1,030 and 970. A nice smooth ripple of flow, and that's how a pulsation dampener works. Now, how do we put it into a system and what effects will it have on that? We're going to show. So I'll clear this. And we're going to draw a pump here that's drawing up out of a reservoir. The discharge piping is coming along, hits our dampener, with the pre-charge, and a lot of times there's a pressure gauge in your system, and we'll have to have an unloader valve in our system that bypasses back to tank, hose, trigger gun, and spray wand. This is what a typical system could look like with a pulsation dampener in it. So again, the water's being drawn out of the reservoir with the pump. It's putting out this rippled pressure. Now we got smooth after the dampener, and what it does is the gauge, the unloader, the gun, the hose, everything is seeing the dampened pressure pulsations, so it's a lot smooth, and the regulator would be trying to react to this pressure wave. If we take the dampener out, now we have the pressure wave getting to here, and the gauge is going to be vibrating more, the needle will be. The seals and piston in this unloader are going to be trying to compensate for this, so you get a lot better life out of your accessories and gun and hoses and fitting connections if the pressure is smooth as a result of putting a dampener in your system. And this is how this system can look. Now, there are different ways to plumb them and things to watch for when using a dampener. The first thing to be cautioned at is you want this charged per the manufacturer recommendation, which is usually around 60%. Okay? Now, if we were to not do that and pre-charge it at, let's say, 20%, then the bladder, when it's in operation, will be deformed all the way up here and could lead to early bladder failure and fatigue. So then the dampener would lose its effect. If we were to charge it at 90%, then the bladder would only move to here during operation and would have very little effect in dampening the pulsations in your pressure line. So again, follow the manufacturer recommendations of approximately 60% pre-charge. All right, this again is one way that it's plumbed into a system. Another way is this bypass line is sometimes routed back to the inlet of the pump so that when you shut the gun off, the water just circulates in this bypass loop rather than taking a second line all the way back to your tank. And this is, for the most part, a good way to do it. Now, to remember is when this happens, when we were at 1,000 psi with the gun open and operating, there's a volume of water in this dampener that when we shut the gun off and it unloads, this volume of water escapes out of the dampener because the bladder will push down with the nitrogen charge and it'll empty the bladder, or empty the dampener. So this flow then will add to this loop. Well, where is it going to go? You're adding a volume of water into a closed loop. Well, what happens is the extra volume of water will work its way through the pump and go back into your reservoir, which is okay. It causes a little bit of pressure spike in this line, but not a lot. But what can further happen is, in the systems, sometimes there's regulations where you have to have a check valve here. Now, this volume of water will get into this loop, but it has no way of escape. And water's not compressible, so what's going to happen is you're going to see an increase in pressure in this bypass line, maybe 300 to 400 psi. And if that happens, this pressure also goes through the inlet of your pump and can take out the low pressure seals and be very detrimental to the lines, because usually these are low pressure lines. And that is why we recommend following the two recommendations of bypassing back to tank whenever possible and keeping your pre-charge at the 60% manufacturer rating.